Okay, we'll kick off then. So hi everyone, thanks for coming along to my session today, which is around Blockchain 101 and Azure Blockchain as a Service. My name is David Borella. I'm a Senior Technical Evangelist at Microsoft. My co-presenter today, Chris, she is a Cloud Solution Architect. And the two of us, we've been going around and we've been doing a couple of blockchain implementations with some of our partners. And so today we want to go and take you through some high-level overviews of the blockchain. So the point of my session today is I want to get you guys amped up and excited about why blockchain is going to disrupt many, many industries and how it's going to do that. This session is not a technical deep dive in how the blockchain actually works under the covers, because you could fill entire days with how the mathematics behind this stuff actually works. I just want to make you guys aware of this technology. And so the agenda for today, I'm breaking down like this. First, I'm going to cover off at a high level what is a blockchain, what are the type of things that it is useful for. I'll then start off by showing blockchain version 1.0 and the type of things that blockchain version 1 tries to solve. I'll then move on to say why you should just move on past that, jump straight to blockchain 2 and the different types of things that resolves for us. I'll then pass on to Chris and she'll cover off what we are doing with our blockchain as a service. And then she'll talk about some of the things in Azure that you can utilize to take advantage of the blockchain. So let's start off with what is the blockchain. Before I do that though, let's talk about how we may do a trade with someone. So if we're going and we're purchasing something over the internet, so they've got a mobile phone that I want to purchase. Typically how this would work is I would go and I would send them the money. Once I've received the money, they would then send me the mobile phone. Roughly how trade works over the internet. But what happens when you send the money to someone and they decide just not to send you the phone? They've just taken your money. What then? Well, how our e-commerce systems have been set up is everything that we do with this, we're always using a trusted third party. There's no way actually for me to send money from me to another person directly unless I get cash and put it into the mail. I'm always going through a trusted third party to send money, whether that's via a bank or via PayPal. And if there's any issues with those payments through fraud or something like that, we can use them because they're the trusted third party. It also means that when we're doing this e-commerce, again, we're not doing it directly, we're doing it via eBay. And eBay is that trusted third party which is going to be there for conflict resolution. If they don't send me the phone, they are going to step in and then they're going to return my money back to me. But it means that we're paying a lot for that trusted third party to be there. What if we could just remove the need for a third party so we don't have to pay those fees? So we could go and use something like Bitcoin, and we could send money digitally from one person to the other, and we could remove the bank aspect, but we've still got the risk that they could just take that money and not send us the phone. So if on the blockchain we use something called a smart contract, we could go and I could put the money, instead of directly to them, put it into that smart contract, and the money is there locked until both of us authorize for the money to be released. They then send me the phone. Once I receive the phone, I send a message saying, yep, I've got the phone. I authorize the money release. They can then say, okay, cool, please authorize the money to be released for me. We've got 2 signatures on this. The smart contract initiates and sends the money off. So in this happy path where everything works well, we've just cut out the third party completely. We've cut out all those merchant fees. Both of us have saved money. Now, sure, things can still go wrong here. If the money is sitting there and they don't send us the phone, then we could have the smart contract just automatically after a week if we both don't sign, because money could be returned back to the person who put the money in there. If there is any further conflicts, then we could bring in a third-party arbitrator still. They could do the conflict resolution for us. We both submit our evidence. They say they sent the phone. Here are all the transaction logs that they did from the FedEx and that. And then they can decide who the money should really go back to, just like conflict resolution usually works. And we could pay them a small fee for that. But in that case, we only have to utilize them when something goes wrong. For the vast majority of the time, we're both going to save money, and we both have a disincentive to try to do anything bad, because then one of us would have to pay for that third party. It also means we've got faster money transfers, because we can send money straight away. Well, there's joke in this area where at the moment with money how it is, it's quicker to send an anvil to China through the mail than to send money to China, because you have to wait days to a week for money to clear through the entire system. Whereas this, you can send money almost instantly. So that is how it could work in a consumer space, but here's a scenario a lot of us here being technical would have done before. We've got our company's IT systems that we need to talk to another company's IT system. Maybe our companies are doing orders between each other. So company A wants to submit an order to company B to create widgets. So how we usually do this, each of the companies have their own data silos with their own database. We may set up a RESTful API between the two companies, and then we send messages over the wire. About roughly how we do things right now, because we both want to hold our own databases. But we've all accounted this, what happens when something goes wrong? We can make sure all the messages get through, but somehow the logic is slightly different on both ends, or an exception's thrown that we didn't expect. Somehow the databases are now out of sync. We think we submitted an order for 300 units. They think it's an order for 500 units. Now we have to reconcile this. Which order is the correct one? Is it really 500? Is it really 300? And both parties have an interest to try to say their version is correct because it's usually financially better for them. So what if, so the next step we usually try to do is we say, well, instead of having two isolated silos of database, let's just create one centralized system. So with this one centralized system, both these companies are there utilizing that one. So we only have that one source of truth. One problem with this usually comes down to governance. Who is going to be the company that owns and controls that centralized data source? Because again, both companies have an incentive to want to be the one who is controlling that. Both of them want to, you'd hope they wouldn't, but both of them would, whoever's controlling it could change the order to be from 300 to 500 if it's better for them. So both of them don't trust the other one to host this. So what if we can remove that need for a trusted centralized system where even if everyone does everything correct, a hacker could still get in there and modify that one database. So instead, let's replace that with a blockchain. If we have the blockchain, both companies can interact with the blockchain. The blockchain, instead of being a centralized data source, is now a decentralized distributed data ledger, which we'll get into in a minute. And so that way, both of them can just trust the blockchain. In this case, the blockchain is a trusted third party. They don't have to trust each other. They can interact with each other, but the shared source of data truth is there in the blockchain. And these two scenarios cover off some of the key value propositions of the blockchain. The top one is the one I'm going to keep on ramming home throughout this entire presentation, which is removing the need for those third parties. The third parties are usually there because two parties cannot trust each other, and so they're there taking a cut of the transactions just for being in the pipeline. So we can try and eliminate them to cut costs. We can increase the efficiency and speed of this. One thing that we've done a lot in the IT world is the promise of service-oriented architecture. With that, the promise was going to be all of our businesses will be able to expose their business processes as a SOA endpoint, and we're going to be able to just hook multiples of them up to create whole brand new value chains. We never really got there just because it was too difficult to interact with each company's unique SOA endpoint. It got a little bit better when we moved to REST. It's been a little bit easier to chain these things up, but it's still a bit of friction. If we start using the blockchain as that one centralized, that one shared data API, then you can start chaining up these business processes from multiple companies and create brand new value. And I'll dive into that later. By removing the need for third parties, making things reconcile quicker, then we can reduce our costs. We're getting better savings because we're removing those merchant fees. And again, the last one, we're reducing counterparty risk. Company A and Company B don't trust each other. And so because we don't have that trust system, bam, we use a blockchain as that trusted third party. So the four key features of the blockchain. First thing is all of this is based on really difficult cryptography. Again, entire sessions can be dedicated to how this cryptography works. In summary, the cryptography there is to secure each of the transactions. You can kind of think of it like private public keys. For a transaction that I want to send, I use my private key to sign the transaction to prove the transaction really originated from me. And I use your public key so I know I'm sending it to you because I can address it directly to your public key. And so it works kind of like that under the covers. Distributed, instead of having one centralized database, which is that central place where one person can go and hack one data source, instead, this blockchain is gone and replicated over every single node throughout the network. That means someone who wanted to maliciously modify some data would have to simultaneously modify it in every single node in the network. Slightly harder than just doing it on one node. Shared, again, what I'm talking about here is trying to chain up those business processes. The more companies and more different people get interacting within that same one blockchain with that shared API, the more value we're going to get from here, just from networking effects and more things that can work together. And a blockchain works like a giant distributed ledger. So ledgers are what's used in accounting a lot. So the blockchain uses a digital ledger. So each transaction is just put one under the other. So I'm sending money from person A to person B, we're transferring ownership of a car, etc. They all go one after the other in a giant transaction log. And these transaction logs are gone and pushed out for each of the nodes in that blockchain. So every single node in this blockchain has a replicated copy of the entire blockchain, the entire data state of the blockchain right now. And how those transactions are actually pushed out to the network is done via the creation of these blocks. So a block starts off right down the bottom of the block. We've got a pointer to the previous block in the chain. So we've got the cryptographic hash of the block before us. So we know we're pointing to that one. We then fill up this block with a whole number of transactions. So it may be put in transactions until this block is full, or time-based ones. So fill it up and we create a new block every, say, 12 to 20 seconds on Ethereum, or every 10 minutes for Bitcoin. We then take that entire block, the pointer to the last one and all the transactions inside of this, and we hash the entire thing, and we get that cryptographic hash for this one block. So we put that block into the blockchain, then we create the next block on the blockchain, which points to the cryptographic hash of the one before us. We then go create the next block, which points to the cryptographic hash before that one. And this is why it's called the blockchain. Each of these blocks are securely attached to the one that came before it, which means that someone can't go in and modify one of the transactions in the transaction log 100 blocks back, because if they do, then the cryptographic hash for that block would have changed, which means the block after it, it's got the pointer to what the correct cryptographic hash is, so we know that someone has modified one of those blocks. So they'd have to go and rewrite every single block from that point onwards, but again, they'd have to do it on every single node in the network. And this is where the security in the blockchain comes from, because it's really difficult to do that. Now, when you're thinking about blockchains, there's three general dimensions that you can look at. So you've got the scope of the blockchain. Do you want to use it in a public blockchain where everything's trustless because there is no trust in the system? We don't trust each other. We don't trust random people in the internet. And so these are for applications that are either consumer to consumer, business to consumer, or business to business if you're just working with a business via their public API. And so some popular ones for public chains are Bitcoin, Ethereum, and all of the alternative coins. There is actually a Donald Trump coin, so there is an alternative coin there. The trading value of it has tanked though. You've also got private chains and private consortium chains. Private chains aren't used too much. They're for fully trusted systems, where inside of your one company where you trust every single node and every single party in here. So it may be large multinationals who have multiple branches around the world, or where they've got large business divisions and they want to streamline it. I don't see that one used very often. What we see and what Chris and I have worked on a lot are these consortium ones, where they're usually industry specific or between a few big companies who do a lot of trade between each other, which could be in, say, a bunch of logistics companies using a consortium chain for their business-to-business backend, or one of the ones that we worked on, which was in the news last month, one we did with Webjet, where Webjet was working with a few of their partners so that they have got a B2B backend for what they're doing with their hotels in the backend. You then got how the blockchain is secured. So it can be secured via proof of work, which is mining, which is why you may hear a lot of things about these Bitcoin miners, and they're making thousands of dollars through mining these Bitcoins. That is only useful in trustless environments, such as public chains where you can't trust anyone. For anything you're doing inside of an enterprise, you're probably going to be using something like proof of stake. And Ethereum at the moment is moving from proof of work to proof of stake. And there's many, many other consensus algorithms out there. The final dimension is this is a blockchain version 1.0 technology or version 2? So let's dive into that. So with blockchain 1, here are a couple of them. So these are the ones that pioneered this blockchain technology. The most popular one, the most famous, is Bitcoin. So if you hear about cryptocurrencies, it's usually this. And that's mainly what these 1.0 blockchains are. They're mainly cryptocurrencies or just for a single use case. If you're wanting to do payments between two people, Bitcoin at the moment is the best one to use, although it is getting rather slow with transactions taking hours to clear through at the moment. If you're going to incorporate any cryptocurrency into your e-commerce front end, so you want your customers to be able to send you cryptocurrency, if you're a merchant, Dash at the moment is probably the one you want to look at. This month, in 1 or 2 weeks, they're going to release an easy widget you can just copy and paste into your web page, so then you can start taking Dash payments. And Zcash has only been around for a couple of months. This one is completely anonymous currency sending. So no one can look up who's been sending money to each other. No one can look up how much money other people have. Whereas for Bitcoin, Dash, and all the other ones, all of that is public information. So blockchain ones, how they fit into the picture is if we look at a standard 3-tier architecture inside of an application, usually what we have is a user interface. It may be a web page. It may be a mobile phone application. We're going to have some sort of UI. Then in the middle, we're going to have the business logic, and that's going to be executing on one of our servers somewhere. Then right down the bottom, we're going to have a data store, usually SQL Server. And so what blockchain version 1 does is it's focusing just right down on the very bottom. It's just focusing on that data store. We're still going to be creating our user interfaces and our business logic as normal, but we're going to have these external business logic going and calling into the blockchain to go and updating that global data state. So some example use cases when you use 1.0 technology. The first one is around ownership. So ownership of digital assets. So the most common one again is around money. So Bitcoin, Dash, these cryptocurrencies are sending money to each other. Trading cards. So many of us here have probably played with something like Magic the Gathering, where you go collect booster decks, you open them up, and then you can use those cards so you can play against people. So you could go and prove ownership of these cards so you can use them in other scenarios, such as for playing Magic the Gathering online. In-game items, so if you're playing something like World of Warcraft, or if you're going and collecting Pokemon on Pokemon Go, it may be that those assets are gone and stored onto a blockchain. So you can go and start trading these tokens, these in-game items between each other. Now, those are for game applications, but you can do it for things like domain names, media licenses. There are people who are creating digital art, because one problem that they said was normal artwork, you can buy it, you can prove who owns this because they're the person who currently does it. There are people who commission artwork to be created just for them, and they want to prove that they're the owners of it. So what some artists are doing now is they'll do artwork on commission and then put a watermark on it, put it up onto the blockchain to say this person now the digital owner of this, they can still go and sell the asset on. And of course, physical assets. You could go and tokenize a physical asset like a car or an apartment to prove ownership, and you can use that to instantly try and get things like insurance. Second biggest use case for blockchain 1.0 is around attestation. So proving that something happened at a point in time. So in the future, you can look back and see and prove that this really happened. So one option could be via contracts. So if you've got your home loan, your house deed, you may go and take that PDF of the document, get a cryptographic hash of that, and then just the hash of it, you can go put that on the blockchain. So in the future, we can see that in blockchain 1234, which we know was 6 months ago, here's what the signed PDF looked like. So then if someone goes and tries to change the variable rate or something like that in the signed document, we can just go get the cryptographic hash, compare what it was on the blockchain and say, no, you've changed that because we know that 6 months ago, the value of the whole hash was this before. We can also do it for things like IoT data. So if you have IoT data where you need to go and prove what these sensor readings were over time, so let's say for global weather. So global weather temperature readings, you could go and put these into the blockchain periodically. So then something like the US government can't try to hide all of the environmental data. We can prove, no, it was in the blockchain 2 years ago. Here were the values. Stop trying to cover it up. And the third good one is around provenance. So this is proving origins of items. So if we have a mobile phone or a car, these things are made up of multiple components. So a phone is made up of batteries and circuit boards. A car can be made up of a chassis and engine blocks. I'm not a car person. So each of these components that make up the phone or the car, each of them have a unique serial number. So each of those components, we can go and get a cryptographic hash of each of those components. We could then go and all of those components get the cryptographic hash of each one of them and put them together and put a cryptographic hash over that, because we're going to get a unique hash which is made up of all of the inputs that came in from all of the unique items that make up this phone or this car. So now we can prove if this car is an original, it hasn't been modified or had any of its parts replaced, because we can go when the car's first made, put in the hash of the car. 5, 10 years later, we can go look at all the components in the car, generate the cryptographic hash, and if someone's gone and replaced the windscreen, then we know that it's not the same car. It's not pure. So that's blockchain 1. So it's got some useful things, but it's just doing kind of passive stuff. So blockchain version 2 amps this up a level. So if we go back to my 3-tier architecture, what blockchain version 2 now is, instead of us having to have external applications that are interacting with the blockchain, instead we can now take that business logic, embed it within the blockchain inside of something called a smart contract. So these smart contracts allow us to put a little bit of business logic in here. It's just a standard programming functions, looks very much like JavaScript, and they can go in there. And these can modify the state of that blockchain for us. It means that we can go and have this shared logic now, which multiple companies can call. So we can say company A puts in an input, company B puts in an input, the smart contract will do something and it may release the funds or collect the votes and put out the output. And so the rise of blockchain 2.0 with these smart contracts is suddenly why you're hearing a whole lot more about the blockchain. Bitcoin's been around for 8, 9 years, but we still didn't hear much about the blockchain until we started getting these smart contract-enabled blockchains, because now we've got this shared data logic. I'll put up 3 of the most popular 2.0 blockchains at the moment. Ethereum is the number 1 in this space right now. That's the one that Chris and I, when we go in and work with customers, all of them have been wanting us to use Ethereum. They don't care about the others at the moment. Hyperledger is one that's being created by IBM. And Corda is being created by R3, which is a consortium of banks. They're trying to create one for the fintech community. But what I wanted to do is I sat down and I spent a whole bunch of time trying to map out a big end-to-end scenario of how you could go and chain up all of these smart contracts in a blockchain 2.0 scenario to create a big ecosystem. So let's start off with a car. So I've already covered this scenario. We've got a factory, the car's made up of a number of components, and now we can prove the origin of this car. Now the thing is though, I said you can get the cryptographic hash of each of those individual components, which then go and make up the car. There's no reason why you can't keep going back down the chain. So how about each of the minerals that made up those components? We can go and say, well, these are the components that were made up from minerals from these mines. So now we can prove if each of these components were made with conflict minerals or not. We could also do it with, say, coffee, prove the provenance of the coffee and see if it is really fair trade organic coffee or not. And actually, I could add this new slide in. So only 2 weeks ago, Microsoft, we just announced something called Project Manifest, where we're trying to help solve this problem. So we're going to be able to track origins of items, provenance of them, attaching RFID so that throughout the logistics, we can go and update the blockchain to say this item has been traveling from this origin to here, to here, to here, combined and moved on. So that's something to watch out for. we've got a car now, and we can prove that this car is this car because we've got it up on the blockchain. So someone wants to buy it. That's too easy though. What if we want a whole bunch of people to buy it? So this car, let's say it's one of the new Teslas that are coming out in the future. So it's one of these Tesla autonomous driving cars, self-driving cars. And these people, they're in a retirement village, and they want to get around more. So what they want to do is, as a group, they want to purchase one of these autonomous cars to try and get them around the city. Now, traditionally how you do this is that group of people that have to trust one person to go and collect the money from each of the people, and everyone have to trust that once they've given him the money, they will really take that money and buy the car, not just go off to Vegas with it. So in this case, why don't we just do a neighborhood crowdfunding? So in this case, all of them can go, invest how much they want to buy in with this Tesla, and once that smart contract has had enough money for it, put into it, then it could go and automatically purchase a Tesla for them on their behalf. And there's a project that does something very similar to this. So up on the Ethereum network, there's something called Wayfund. And what they're trying to do is a decentralized Kickstarter. So if you think about Kickstarter, again, Kickstarter is a trusted third party that we're doing to collect the money on the behalf of the person raising the money. So Kickstarter is taking quite a significant chunk of that money for doing that. So if we can do crowdfunding through a smart contract, we're removing one of those third parties, and now the person who's doing the crowdfunding is going to get more of that. We're cutting out those merchant fees. This community has now purchased this car, and it's going okay, it's getting them around the place, but they're starting to have arguments. There's now an issue of governance over this car, because some people wanting to use it more than other people want to use it, and they're starting to fight over the car. So what they need now is some sort of governance model, so they can go and start organising how this car is used. So it's coming up that the car, it needs to go in for its service, but some people want it to go in for the service, and the other people don't want to pay the money to do that. So if we did it in a decentralized governance way, they could start voting on this stuff. They could put in a proposal saying, we should get this car serviced. The people who have put in the money, they will get voting shares based on how much money they put in originally, and now they can vote on what happens with this car. And again, there's a project that is doing this right now. Again, up on the Ethereum network, there's Boardroom. So this allows decentralized governance. You put up a proposal, everyone votes on this, and if the vote is passed, then the funds can be released to do something. And so you could chain that up to another smart contract. Now, that stopped all the fighting. They're working well, they're sharing the car and voting on how things should be done. What they're finding though is the car is sitting there unutilized for a lot of the time. And if you read Elon Musk's blog post recently, he talked about one thing that these autonomous Teslas could do is when you're not using it, why doesn't it just go off and earn you money by doing some ride sharing? So we've got a passenger and they want to use our car. How do they organise a trip for us, and how do they send us the money? Well, that's why we're using a trusted third party again, such as Uber. So Uber is taking a chunk of the money just for being that trusted third party. So what if we did this as a smart contract? So what can happen now is we cut out the middleman, we start doing decentralized ride sharing. The passenger can go send us some money. The money would go through that ride-sharing smart contract. They may take their small percentage, which would be smaller than Uber. The money goes up into our decentralized governance thing, which will then go and distribute the profits out to each of the shareholders based on how much they had. And this is, again, why Blockchain 2 is enabling these type of things, because these smart contracts can be programmed to release funds based on whatever we program into it. Now, it is here. We've got this ride-sharing happening, but we need to pay for insurance for this car. Now, because we've got the token asset for the car, we can go and call a smart contract with our car token and say, well, I need insurance on this car. But this car, a lot of the time, it's just sitting there doing nothing. So what if we could have insurance that's covering the car when it's just sitting there normally, and then when we're picking up a random passenger who we don't know through the ride sharing, why don't we, just for that, purchase insurance just for that one ride? Well, we could do that via the blockchain. In fact, if we jump up, there's a website called State of the dApps, which are listing a whole bunch of smart contracts are doing these type of things up on the Ethereum network, and there's a whole bunch of different insurance ones there. There's even one for if your flight is delayed, you can get compensation, flight compensation insurance via that. And Swarm City is currently, they just finished their fundraising round to do that decentralized ride-sharing platform. Now, we've got a passenger in the car, and they want to listen to some music. This music is, of course, created by an artist. Now, in the music industry, I've been talking a lot about third parties who are taking big cuts of things. In the music industry, these artists are getting, what, maybe 10% of the money for each of these song sales, because things like the record labels are just taking the vast chunk of it, which isn't really fair. These artists, these creative people, are the ones who are creating all the content and all the value, but they're only getting a very insignificant chunk of the money. So what if we had a decentralized music platform? Rather than, say, something like iTunes or Spotify, which then goes through all of the record labels, what if the artist could just short-circuit all of that and then just sell their music directly to not passengers, directly to their customers, to their listeners? That way the artists are going to get much more of that value because they're cutting out those middlemen. If we do that though, and we've got it as a smart contract here to do these music sales on our behalf, it can then go and unlock other potential. So for example, let's say up on YouTube, we've got advertisements up on YouTube. So what if it just went and purchased the licensing rights for that music for the advertisement just per time that advertisement is played. So you don't have to buy a big license for the music up front, just per play. Or something like Spotify, where each time that music is streamed, then they just pay a small fractions of a cent to pay for the rights of that music just for that one stream. And you guessed it, this is being created right now. So up on the Ethereum network again, Ujo Music. Then this is a decentralized platform for artists to go and sell their music. So the example here is an artist called Imogen Heap, who put up her, one of the tracks called Tiny Human. Ujo Music is still in alpha at the moment, so they only put one up there. But here you can see around the song of Tiny Human, we've got things like the mastering engineer, the brass ensemble, the percussion, Imogen Heap, who was the main artist on this. So inside of the blockchain network, you can see each of the people who contributed to this one song. So then when they're, I'll get to the slide in a sec. So then when the money is put in for that song, that money can be split up over each of the people who contributed to it. So you could go and purchase that song outright for 60 cents just for that song. You could go and per stream, it's what, a sixth of a cent per stream for the advertising. And here we can see the distribution of it. So the main performer, Imogen, is going to get 91% of those sales. Again, just calculated by the smart contract and distributed automatically. And each of those other people, like the percussion and that, the mastering, are going to get a smaller chunk. But it's all visible inside the smart contract, so the artist can see the list of all of the transactions for this song, and they can make sure that they're not being cut out of how much money they should be getting. Cool, so our passenger's happy, they've got money coming in. But everything that's happening here so far works well for the first world, where we've got bank accounts and we've got money and we can send the stuff around. What about people who aren't earning enough to even have a bank account? So in the world, worldwide, there's approximately 2.5 billion people who don't even have access to a bank account because they don't even earn enough money to cover how much the bank fees will be in a month. So at the moment, these people are locked out of the global economy. They can't interact with the global economy. It also means that they always have to carry the money on them. If they want to do any purchasing, they have to physically take the money and take it with them, which means that they can only buy things which are there within their village. If they want to buy something from someone who's in another village, they have to physically go there, take it and give them the money. So even between two villages in a community, they're not being able to trade with each other. So what if we gave them a digital wallet? So they had a digital wallet, they're now banked, they're now part of the global economy, they can now hook in to this global economy and start interacting with it. Like sure, for us, we may not care about that segment of the market because they've only got a couple of cents to dollars in their digital wallets. But it does mean that they can interact with each other. They can now be in the same community or the same village and do those transactions, or they can now do things worldwide. Because now that they're a part of the global economy, now they can be creatives. Now they can go and create music which would go up in Ujo Music. They can create these new songs, and each time those song is purchased, now money is coming into their bank account, which was impossible before because they couldn't even afford a bank account. So they could create music, but let's go back to the car. So this car, so all of these smart contracts, the actual name for these are called dApps. They're decentralized applications. Now, let's say the Tesla dashboard, maybe there's a marketplace there where you can buy apps to put up on there. And so this creative wants to create a decentralized app. Now, they could do that, but let's say that they're blocked because they've created this really cool smart contract to do something inside of the Tesla, maybe to get the weather better or give them driving routes. Now, they've created it, but they can't get into the Tesla store because you need to put up, say, $100, $200 to submit an app into the App Store. I'm just making things up here. So with that, they're blocked because they don't have the funds to do that. So up the top, we had neighbourhood crowdfunding, but with communities like this, we usually do things around microlending. So what if we created microlending smart contracts where we could go and put money in, and whenever they hit milestones, we can release little trickles of this money out to them. And so microlending does things around education. So when students are going and hitting each of the semesters, little bits of the money are being released. We can do the same thing here when they reach milestones. When they release the first version of the dApp, then they get some of the funds. When they're about to submit it to the App Store, then they can get the vast majority of the funds so they can submit it to there. It also means, because these are all smart contracts, it can be chained back down. So when users inside Teslas are using this application and the application is generating profits, the profits chain down into the microlending contract, then all of the lenders can go and get a portion of the profits to pay them back, and then some of it can go back down to the creative. Once all the lenders have been fully paid off, then the microlending smart contract can just start funneling all the profits straight down to the creative once they've paid back that loan. Okay, everything we've been talking about here is in the public blockchain. So in the public Ethereum blockchain, this is an example of how all these smart contracts could be chained together to provide some value. But we can also start using some private consortium blockchains. So this factory, it's going and it's getting items from its suppliers. There's logistics around how do these things are sent around. So they can set up a private consortium blockchain between the factory and who it works with. And that can just be back-end B2B business. Up the top there, I've got regulators, safety testing, emissions testing. So maybe these cars, for regulatory compliance reasons, all of these companies and these testing ones in the government can have their own private blockchain for all around regulation. So all of the test and emission results, the ones which we've seen are being fabricated by some car companies recently, well, they can go and attest that these test results are correct. So later, we can go and point back and say, no, you said the test results were this. Now, all of this can be hooked up together. Now, some people think there's going to be one blockchain to rule them all. It's not going to be the case. We're going to see many, 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 many blockchains. We're going to see a couple of public blockchains. We're going to see heaps of private consortium blockchains where it makes sense for companies to work together, like we're seeing here. And you can get these blockchains to interact with each other. So we've got that safety and compliance testing happening up the top, and those ones can, the emissions testing, we can go and attach it to that, the public blockchain for that car to say, this car was done with these emissions testings. Now, I covered all of that. One thing I haven't touched on yet is identity. So all of the people who live in that retirement village who want to interact with this, they need to prove their identity somehow. And that creative and the passenger, all of them need to have an identity to interact with this. And right now, a lot of things that are happening around identity is around centralized identity. We're usually using things like a Facebook login. So Facebook is a centralized identity service, and they own our data. We've got Twitter, we can log in with a social account, they own our data. So if I'm me, why don't I own my identity?
Oh, whoops, my microphone fell off. Uh-oh.
I got a little too excited, sorry. Why don't we own our identity? So there's another big project happening up here called UPort. So this allows for self-sovereign digital identity systems. Now, I own my identity. I no longer need those trusted third parties to hold my identity. I can do this myself. And this is one of the big things I'm really excited about. This will allow us, for privacy, we can fight back and we can now own our identity, our privacy. It's no longer Facebook taking all of our data and information. We can take that control back. So all those are some real-world examples that I'm seeing right now, but that's only just scratching the surface of some of these smart contracts that have been created right now. So jump up with the state of the dApps. There's heaps of smart contracts there that you can go look at to get an idea of some of the projects that are being worked on right now. Chris and I are going to be around all week. We'll be at the opening party tonight, so please just come speak to us. We'd love to answer some of your questions. So with that, thank you very much, guys.